Hi, I am Dr.T.S.GEETHA, Professor of EC Department, S.A.ENGINEERING College. Today I am going to take a GATE syllabus of communication systems. So this is our mission of my institute and department. Now we'll discuss about some syllabus of communication. Right here, first topic is random process, that is autocorrelation, power spectral density, properties of white noise, filtering of random signals through LTI systems. Then analog communication. In analog communication, amplitude modulation and demodulation, angle modulation and demodulation. Then spectra of AM and FM, super heterodyne receivers. Then information theory. Under information theory, entropy, mutual information and channel capacity theorem. Then coming to the topic of digital communication. In digital communication, pulse code modulation, differential pulse code modulation, digital modulation schemes, that is nothing but ASK, PSK, FSK, QAM, bandwidth, intersymbol interference, then map ML deduction, matched filter, receiver, SNR and BER, bit error ratio, then fundamentals of error correction, Hamming codes and CRC. These are the syllabus of GATE. So first we will discuss about communication systems. What is meant by communication systems? What are the parameters is coming under communication systems and classification, everything. So here what is meant by communication means the transmission of information from the sender to the receiver through some medium, that is called communication. So what are the elements of communication systems means information source, transmitter, channel, receiver, destination and noise. So noise is added in the channel. Okay, what to be transmitted? Anything, mainly audio, video or any other data that is in low frequency range. Okay, so that should be transmitted through communication channel. So although it's common, everything that is it is common in our experience that sending or receiving signals or data is simple, but it involves quite complex procedures, possibilities and scenarios within your communication systems. So next one is some problems we are facing in communication, that is to send information. So that in that particular time we are facing some problems. Okay, so that is long distance transmission. Suppose your low frequency signals is attenuated in space. So at that time high frequency do not attenuated in space. As fast as low frequency we can travel along long distance. So this happens as energy of signal is proportional to the frequency. So low frequency are used for some application that the strength will be less or resulting to a reception. That is, low frequency signal get attenuated quickly in space. High frequency signals is not attenuated. Okay, because of this we need some long distance transmission. So next one is antenna size. So antenna size is inversely proportional to the frequency of the radiated signal. The order of the antenna aperture size is at least 1/4 of the wavelength of the signal. So its size is not practicable if the signal is 5 kHz. Therefore, rising frequency by any process is required to reduce the size of the antenna. So next problem is signal to noise ratio. So electrical noise is one of the principal factors in the performance of the communication system. So the signal to noise ratio indicates the relative strength of the signal and the noise in the communication. So stronger signal and the weaker noise, higher signal to noise ratio. So signal to noise ratio is a main problem in communicating things in the channel. So next one is interference. interference of different transmitted wave. So in that, signal transmission, the signals from various sources are transmitted through a common channel simultaneously by using some multiplexers. If these signals are transmitted simultaneously with certain bandwidth, they cause interference. Next problem is instrument cost. So instrument cost that is used in low frequency range is very high compared to high frequency based instruments. So cost of the instruments is very much important. Next one is modulation. So what is meant by modulation? Modulation is a process of changing the characteristics of a wave. So wave is nothing but signal. That characteristics of the wave to be transmitted by superimposing the message signal on the high frequency signal. For example, message signal is low frequency signal. This low frequency signal is imposed with some carrier signal. So that carrier signal should be high frequency. So both signal is to be transmitted through the channel. So by this two signals are combined in some equipment or thing that is called modulator. So this carrier wave can be DC or AC or pulse chain depending on the application used. Usually high frequency sine wave is used as a carrier signal. So in modulation technique, the message signal frequency is raised to the range so that it is more useful for transmission. Next one is why we need modulation. So there are some points, that is reduction in the height of the antenna. So that is main problem we are using modulation, that is particularly for long distance transmission. So first one is reduction in the height of the antenna. Next one is avoid mixing of signals. Then third one is increases the range of communication, that is longest distance of communication. So next one is multiplexing. Multiplexing is possible in modulation, improves quality of reception. So multiplexing is a different concept and modulation is a different concept, but through modulation, multiplexing is also possible. So modulation is important to transfer the signals over long distance since it is not possible to send low frequency signals for longer distances. Similarly, modulation is also important to allocate more channels for users and to increase noise immunity. So for example, we consider amplitude modulation waveform. So this is a message signal, that is modulating signal that contains the information. This modulation signal contains some information, and generally that modulating signal is lower frequency. Another one is carrier signal. Carrier signal is used to transmit a message signal. That carrier signal should be in higher frequency. This one is amplitude modulated carrier, that is modulated signal, that is resultant signal due to modulation, that is the output of the modulator. Next one is classification of modulations. Usually, types of modulations is based on the application. So types of modulation is divided into two. One is continuous wave modulation and pulse modulation. So continuous wave modulation, amplitude modulation and angle modulation. Amplitude modulation, there is no types. So in coming under angle modulation, there is two types. One is frequency and another one is phase modulation. So these and all coming under continuous wave modulation. Next one is pulse modulation. Pulse modulation, so pulse is basically two types, analog pulse and digital pulse. So pulse modulation is two types, analog modulation and digital modulation. So analog modulation is divided into pulse amplitude modulation, pulse width modulation, pulse position modulation. Digital modulation is pulse code modulation. So pulse code modulation is a basic version of digital modulation. So the advancement of pulse code modulation is delta modulation. So advancement of delta modulation is adaptive delta modulation, and go on. So this is the classification of modulation. So first we will discuss some basic type of modulation. So amplitude modulation. Amplitude modulation is continuous wave modulation and also called, sometimes it's called analog modulation. So amplitude modulation, amplitude of the carrier is varied in accordance with the instantaneous value of modulating signal. So this is an amplitude modulated wave. Next one is frequency modulation. Frequency of the carrier is varied in accordance with the instantaneous values of modulation. modulating signal. Next one is phase modulation. Phase of the carrier is varied in accordance with the instantaneous value of modulating signal. So this is a basic waveform of amplitude, frequency and phase modulation. So this is positive, this is negative. So here frequency is changing. So here phase is changing. So here amplitude is changing. So this amplitude and frequency, phase, everything is this under all characteristics or parameters of signal. Okay, so these signals are varying based on the carrier or message signal. So this is a basic equation of modulation, that is AC cos 2 pi fct plus phi. So here AC is nothing but amplitude, this is frequency, this is phase. So combination of frequency and phase is nothing but angle modulation, already we discussed. So angle, that is frequency, that is equal to rate of change of angle. Okay, so in this equation we have to change frequency, that is FC, that means frequency modulation. If we change AC, that is amplitude modulation. If we change phase, that is phase modulation. This is a basic equation of modulation. So this is amplitude modulated wave. So here this is amplitude, maximum amplitude, minimum amplitude. This is coming under time domain. So this is amplitude modulated wave. So these are the common frequency ranges. So common frequency ranges, that is based on the classification. That is, what are the classification? That is audio frequency range, speech band, very low frequencies, medium frequencies, high frequency, very high frequency, ultra high frequency, super high frequency, extra high frequency, like that. Okay, so these, based on these frequency band is allocated. So usually the frequency band of 20 Hz to 21 kHz is the total band that the human ear can hear. Okay, so there are different types of signals that are processed or transmitted or received by telecommunication equipment. So these are, that may be analog or digital. So each type, that is analog or digital or any signal is divided, or that type has some individual characteristics. Okay, that each type has individual characteristics. So based on the characteristics or parameters of the signal, so the frequency f of the analog wave is determined by the following formula. So that is f equal to 1 by t hertz, where t is time in seconds, time t is the duration of one complete cycle. Okay, that is one wavelength. So the formula is this formula, f equal to 1 by t, that is used to determine the wavelength in free space. So wavelength, formula for wavelength is c by f. C is the velocity of light in your vacuum, so that is 3 into 10 power 8. Then the waveforms, already we see, no, that waveforms, all waveforms is coming under time domain. So the sine wave and cosine wave consist of a single frequency. A complex wave is a wave that consists of number of different frequencies. So how we measure the signal? So we need to measure the signal level, right? So that signal level is measured by using or something gain or loss of a network, that is expressed as a ratio of output power to over input power. If the output power is greater than the input power, then the network has a power ratio is greater than 1. That means that the network has a gain. So output, that power ratio is greater than 1 means that network has a gain. So the power is less than the input power, that is power ratio is less than 1 means that network has a loss. Then the power ratio is equal to 1 means that is unity gain. So instead of measuring the power, a signal dissipates in watts, that is easier to measure in a signal level. So the unit of measurement that is, instead of measuring the power a signal dissipates in watts, it is easier to measure the signal level. So the unit of measurement is the bell, but this is a rather large unit of practical purposes. So instead that bell, decibel is used. So the decibel, that is dB. The dB is 1/10 of a bell, that can be defined as a loss or gain of a network. Gain of the network is logarithmic form. So n ratio, so that is P out by Pn. So this equation is to calculate the ratio of both output power and input power, that is in watts. To enable the unit of measurement to be attached to this ratio, that is the following formula, that is based on logarithmic, n equal to 10 log base 10 P out by P in dB. So the decibel is 1/10 of the bell, already we discussed. Then the advantage of using the decibel as a unit of measurement is that the individual gains of the individual networks, that to be added together instead of being multiplied together. For example, determine a formula for the overall gain of the 3 cascade network. Here 3 network are there. 3 network is there. So n ratio, we need to calculate the n ratio. So output by input. So first one, this n, P1 by Pn, P2 by Pn into P out by P2. Okay. So output n equal to P out by Pn. So here, to convert this into dB, 10 log base 10, the multiple factor. So that is to be added. So this equation is converted into this. By using this formula, we need to calculate some. By using this formula, the example, that is calculate the gain or loss of each of the following networks in dB. The input power is 4 and output power is 16. So then we substitute this values in this equation, and this is the final value, 6 dB. Next one is dBm. The unit of measurement is used to measure the actual power at the point is a system relative to 1 millivolts. So this indicates whether the out power at the point is greater than 1 milliwatt or less than milliwatt. So the dBm is defined as the gain or loss of a network, where the reference signal power is 1 milliwatt. So 1 power divided by 1 milliwatt. This is one formula. So that is determine the signal level for each of the following signal powers in dBm. Okay, so this is an example problem. So continuation of this problem. So you'll substitute, suppose 16 microvolt. So that is substitute here, and we will get 17.96 dBm. So based on above example, the level of dBm indicates the actual power in a signal relative to 1 milliwatts. So this is the relationship between power and dBm. So power 16 means that level of dBm is plus 12. So 8 means plus 9. Like this is a relationship between power and dBm. Okay.
Thank you.